Hello everyone, Multipro here. We're going to learn more about Algebra 1. We're talking about equations and formulas today. So if you haven't already, hit that subscribe button below the screen. If you want to learn more about algebra or other maths, even science, engineering. So today we're going to have two things we're going to cover. One is we're going to solve equations for given variables. And then the second thing is we're going to use formulas to solve real world problems. And this is real exciting to me because my job is to solve real world problems. I'm given real world problems every single day to solve. And my team and I, we work towards this every single day that we work to solve these real world problems. So this is going to be a fun lesson, and I hope you enjoy it as well. So what we're going to do, we are going to dive on in. Okay, so let's imagine that we have a roller coaster. Okay, and this very high part here is 195, that was terrible, 5, try again, 5 feet. And then we're going to label this one as H. Okay? Let me tell you a little bit about this roller coaster. So, a roller coaster starts with a vertical drop. So that's this part down. Whee! You go down. Okay? Of 195 feet, as we've shown. And then ascends a second shorter hill. Okay, and we've labeled that as H. Suppose we want the speed be 49 miles per hour. Sorry. Not this problem, it's not mile per hour. Feet per second. SEC, Southeastern Conference. When it reaches the top. Okay? So when we get up here, we want to be at that speed, 49 feet per second. So what we're going to do is, ignoring friction, the equation G times 195 minus H. So 195 comes from over here, and H comes from over here, equals 1/2 V squared. Can be used to find the height of the second hill. Okay, we're going to use this equation. So G is gravity. Oh, we don't want to come yet. G is gravity. Oh, we erased our Y. With an acceleration of 32.2 feet per second squared. H is the height of the second hill, as we've drawn, and V is the velocity. So velocity is speed and direction of the coaster at the top of the second hill. Alright, so very wordy, but we got this, no problem. Okay, so let's write this out. Let's plug in the gravity for G. So 32.2 times 195 minus H, or H as my Indian friends say, is equal to 1/2. Alright, now V is velocity. So what do we want to get up to? We want to get up to 49 feet per second. So 49 squared. Alright, so if we multiply this out and we use our handy dandy calculator, we get 6279 minus 32.2H is equal to 12.5. Okay, so then what we're going to do is we're going to move this term over here. So we got to subtract that from both sides. So we get minus 32.2H is equal to minus 5078.5. So therefore, if we divide both sides by negative 32.2, we get that H is equal to, well, roughly, let's redraw this, let's not be sloppy, is approximately 157.7 feet. Okay, so if we want to be going 49 feet per second, when we go down this hill and back up, at this point, if we're going 49 feet per second, then this height needs to be less than 195, and it's 157.7 roughly. All right, not too bad. Very wordy, very lengthy, has a whole sketch, look at all this. But then we only had 2 lines of equations, pretty easy to solve. We got this. All right, so let's look at an example. Example 1. All right, we want to solve x minus 3y equals 7 for y. Okay, we want to figure out what is y. So basically, in order to do that, we just have to get y on one side of the equal sign and everything else on the other side. So since y is already on the left, let's leave y on the left side and put everything else on the right. So we got to subtract x from both sides. So if we do that, we have minus 3y is equal to 7 minus x. Okay. Now we want to divide both sides by negative 3. So y is equal to 7 minus x over negative 3. Or we could write this as negative 7 plus x over 3. Either way. So we found the answer. That was pretty simple. Great job. Alright, so let's look at another example here. Example 2. The circumference. So that's the distance around around a circle. So the circumference of a circle is c equals to 2 pi r, where c is circumference and we don't need a comma, lost 3e, and r is radius. And pi is about 3.14 blah, 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 blah. Okay? Just for your information. Alright, so we have two things we want to do here. One, we want to solve, actually more than two things. Sorry, only two things. Solve for radius r. So all we're going to do is get r completely by itself. Okay, so we're using this equation up here. So I'm going to just leave r on the right hand side, and we're going to divide everything by 2 pi, the right side and the left side. So if we divide by 2 pi on the right, the 2 pi goes away. It just becomes 1. So then c over 2 pi is r. Great job. Now, part B. If the circumference, let's try to spell this, circumference of a hailstone, so that's those balls of ice that fall from the sky. I remember when I was 6 years old and I heard the meteorologist on TV say the word hail, and I thought it was a bad word, and it actually started hailing at that moment. And my mom said, go outside and you'll see what hell is. And it was not what I thought. I thought it was going to be a burning place, and it was actually a piece of ice. It felt like ice cubes were hitting me in the head. It actually kind of hurt. Alright, so the circumference of a hailstone is 9 inches, so the distance around it's 9 inches. So we want to find the radius. Well, we already have the equation, right? We found the equation here. So we're just trying to solve for r. And we're given that c is 9. So r is equal to c over 2 pi, which is equal to 9 over 2 pi, which is approximately equal to 1.43 inches. So the radius of that hailstone is 1.43 inches. That is a pretty big hailstone. That will do some damage. Alright, let's look at one last example. And this one's going to be quite fun, I think. So you tell me if you think it's fun in the comments. Alright, the formula S is equal to 1/2 AT squared represents the distance S that a free-falling object will fall near Earth or Moon in a given time t. Okay? So we got a couple of variables here. We have S and we have t. Alright, now A is gravity. So we got another variable now. We have A. Alright, so what are we supposed to do here? Part A. We want to solve for A. So basically we have to get A completely by itself in this equation way up here, okay? So what I'm going to do is divide by 1/2 of t squared on both sides to get A completely here on the right. Okay, so that gives me 2s over t squared. Ah, what happened? T squared. Okay. Alright, so we solved it. That was pretty easy. Now, part B. So a free falling object near the moon drops 20.5 meters. Oh, that's a bad looking 5. In 5 seconds. Okay. What is the value of A for the moon? Interesting. Okay. So we already have the equation up here. So we're just going to plug in some stuff and find out what A is. So A is equal to 2 times, alright, so we fall this distance S, remember? Get lost here. Okay, S is the distance that it falls, free falling, right? So that's 20.5. And then T is the amount of time, 5 squared. And that gives us 1.64 meters per second squared. So we just found the gravitational constant of the moon. This is pretty interesting. Alright, part C. Is the acceleration greater or less than Earth? Well, do we know what the gravitational acceleration is on Earth? Well, so let's relabel this as A sub m for moon. And we're going to say A sub e for Earth is 9.81 meters per second squared. Now when we build the metric system, we use S for seconds. But when we use the United States customary system, we use SEC because the Southeastern Conference. That's not really why, but that's how I remember it. We have a different abbreviation for seconds. Alright, so the gravitational acceleration of Earth is 9.81. And we found that on the moon is 1.64. So is A sub n greater than or less than A sub e? It is less than. So the answer is less than. So A sub m is less than A sub e. Okay, now let's try to figure out this. Would someone weigh more or less on the moon? So let's talk about, we need an equation. So how do we find the weight of someone? The weight is their mass times this acceleration. Okay? So we do not know what m is, but we know that if A is bigger, that makes W bigger. If A is less, then W is less. Because if we multiply by a bigger number on the right hand side, then the number on the left gets to be bigger. If we multiply by a smaller number on the right hand side, then we get a smaller W over here. Okay? So, in comparison with the Earth, would someone weigh more or less on the moon? They would weigh less, right? A sub m is less than A sub e. So therefore, W of m is less than W of e. So their weight on the moon would be less than what they'd weigh on Earth. Some people would like to weigh themselves on the moon so they don't think they weigh so much. All right. That's all we had today. I hope you enjoyed. I'll see you all next time.